I don't think they'll do that. So today we're doing 2.6. Yeah. Graphs. Did I? Yes. Graphs of rational functions. Rational, remember, means that it's in fraction form. So it's any graph that has a function that's in fraction form, right? So some of the things we're going to need today are, you need to have your asymptotes. You're going to need to be able to find x and y intercepts. And we're going to talk about end behavior. All of these you already know. The only thing that's going to be new today is talking about end behavior in our new form, using limits. Okay, instead of just saying up, up, down, down, or whatever, we have to use limits when we talk about our end behavior. All right, so first of all, let's start with, since you know all of those to begin with, get that out of my way. Let's start with example number 1. Let's say I have g of x equals x minus 2 over x squared minus 2x minus 3. And I want you to find asymptotes, x and y intercepts, and then I want you to sketch the graph. All right, so first thing we have to do is we've got to factor that denominator. Okay, so if I factor that denominator, I can draw my little x over here, negative 3 on top, negative 2 on the bottom, be negative 3 and 1, right? So I have x minus 3, and I have x plus 1. All right, so first, do either of those factors cancel at the top? So we have no holes in our graph, right? We have vertical asymptotes at x equals, what makes this one 0? 3. And then at x equals, what makes this one 0? Negative 1. Good. So we have no questions how to find vertical asymptotes. We've been doing that a long time, right? Horizontal asymptote. Y equals, remember that we take the highest exponent and we take their coefficients. The highest exponent in this whole function is x squared. So how many x squareds do we have on top? 0. And how many do we have on the bottom? 1. 0 over 1 equals 0. So we have a horizontal asymptote at y equals 0. So far we have those two. That takes care of the first thing I asked for. Now we're going to do x and y intercepts. To find the x-intercepts, we put 0 in for y. So I'm going to put that here. To find x-intercepts, put 0 in for y. All right. So I'm going to put 0 in here. I get 0 equals x minus 2 over x squared minus 2x minus 3. Well, to get rid of this denominator, I have to multiply both sides by that, right? Which just cancels it. If I multiply that times 0, it goes away, right? So what I really have here is 0 equals x minus 2. What does x equal? 2. So we have the point 2, 0. Okay? To find the y-intercept, we put 0 in for x. So to find y, put 0 in for x. All right, so if I put 0 in for x, I have y equals 0 minus 2 over 0 squared minus 2 times 0 minus 3. So I have on top a negative 2. On the bottom, this is 0 minus 0, right? 2 times 0 is 0, minus 3. So really we get 2/3. So we have a y-intercept at 0, positive 2/3. Okay? Are we still all doing good? That's stuff we've done before? All right, so now we're going to sketch the graph. You come down here. I have a, oops, I lost it up here. We have a vertical asymptote at 3 and negative 1. So I'm going to go out to 3, put a vertical asymptote. I have a vertical asymptote at negative 1. I'm going to put a vertical asymptote. We know that it's going to cross the x-axis at 2, 0. Plug that one in. It also says that I have a horizontal asymptote, gentlemen. I have a horizontal asymptote at y equals 0, which is the x-axis. Well, how is it that if I can't cross the x-axis, but I can actually have a point on the x-axis? It's going to cross in the middle, but it can't cross on the outsides, right? We also know that it's going to cross at 0 and 2/3. So at 0, about right here, it's going to cross. Yeah, it is, where the point crosses. It's because this middle section right here, it's going to probably do one of these deals where it's approaching each one. Okay? I haven't graphed it to make sure. I'm going to guess that it can approach this one out here, so we're going to have this section, and it can approach out here, so we're going to have this section. That's what I'm going to guess. Will you please graph and see how close I am to that picture? All right?
Oh, that might.
You did not. Here. Parentheses around the bottom, around the whole bottom.
Oh.
Okay, I'm good? Okay. All right. So one of the things I want to talk about now that I have this graph is the new thing that we haven't discussed yet. How many end behaviors do I have in my graph up here? How many arrows do I have? Oh, careful. I have 6, right? There are actually 6 end behaviors on this graph. We need to talk about all of them, yes. Okay, well, so we're going to start with this one. This is one we've talked about already. The limit, actually let's put it in a different color so you can see it. We're talking about this one right here. This is the limit as x goes to negative infinity. What is this arrow, this graph, getting closer and closer to? It's getting closer and closer to 0. This is 0. Let's talk about this end over here. This is the limit as x goes to positive infinity. What is this piece of the graph getting closer and closer to? 0, right? This is getting closer and closer to 0 right here. Okay, so this one equals 0. All right, so we're good with those 2 ends, right? So we got 2 out of the 6 done. Let's go to this one next. This is the limit, and this is going to be something new, as x approaches. Now, x is getting closer and closer to this asymptote of negative 1. So it's approaching negative 1, and then to say we're... All right, so as I was saying, Now, because I'm coming or approaching this asymptote from the left side, I'm going to put a little minus sign at the top, saying I'm coming from the left. So as I come from the left to this asymptote, where am I going to? Negative infinity, absolutely. Okay? This one, I'm approaching the same asymptote, the limit, as x approaches -1, but this time I'm coming from the right-hand side, so I'm going to put a little positive at the top. And where is this one going to? You too, thank you. Positive infinity. All right, so we have 2 more to go. This one is the limit as x approaches the asymptote of 3, and it's coming from the left side, so I put a little negative at the top. And where you too, thank you. Not for all of them, but negative infinity. And the last one, this is the limit. As x approaches 3 from the right-hand side, it's going to positive infinity. Uh-huh. Okay. So you've got to do every end, right? This end is going this direction. Oh. Oh. Why are we having to do this one coming from the left and this one coming from the right? No. Uh-huh. Uh-huh. This? Because that's part of the graph. Remember, one of the things we talked about is the fact that usually when you have a graph, and like if you had 4 quadrants, it's usually in 2 of them, right? Uh-huh. Okay. It's going to be okay. It's the first time I just gave you all this. All right, so let's try this. You guys are going to be fine. So here's example number 2. All right, let's narrow it down a little bit more. So in the first 2 problems, so 2 and 4, use limits to describe end behavior. All right, and let's do f of x equals 1 over x minus 5. All right, so on this one, first of all, we have a vertical asymptote where? At 5, very good. 1, 2, 3, 4, 5. Vertical asymptote at 5. Where do we have a horizontal asymptote? 0, right on the x-axis. Okay, and your sketch is going to go from here and over here. Okay, so now how many ends do I have here? 4. So how many end behaviors do I have to have? 4. Okay, so we're going to start here with this one. This is the limit as x goes to negative infinity. This approaches your y asymptote, or your horizontal asymptote, of 0. On the opposite side, the limit as x goes to positive infinity, it approaches the horizontal asymptote at 0. Okay? Now here are these other 2. This one is the limit as x approaches our asymptote of 5 from the left. Where is this going to? Negative infinity. This one is the limit as x approaches our vertical asymptote of 5 from the right. It's going to positive infinity. That's okay? We're good? The extra pieces, but yeah, it's because it depends on how many sections on the graph there are. Yeah. All right, so we're good on the first 2. Graph them, look at your limits. Yep. All right. Let's go to example number 3. Example 3. All right. Describe the translation of the reciprocal function f of x equals 1 over x, and then identify vertical and horizontal asymptotes. So I'm going to give you the function y equals 3. Whoops. Try that again. Goes 3 over x plus 4. All right, so first let's talk about the translation. Well, that's what the parent function was. Okay, so that means that this 3 is a stretch of 3, right? Stretch 3. Gentlemen, stretch 3. And on the bottom, we have x plus 4, which means we're going to the left 4. All right. We have a vertical asymptote at x equals -4. And we have a horizontal asymptote at y equals 0. Okay? So let's go ahead and sketch this. So we have a vertical asymptote at -4, horizontal asymptote at 0. Again, it's going to be in the first 2 quadrants because it hasn't flipped. If it was negative, it'd be in 2 and 4, right? Okay? Now, let's quickly add this in. What are our 4 end behaviors? This one over here is the limit as x goes to -infinity. It equals 0. This one is the limit as x goes to +infinity. It is 0. So you'll notice the limits as they're going to positive and negative infinity are going to your horizontal asymptote. Now we're going to talk about the vertical asymptote here. Down here, the limit as x approaches our vertical asymptote of -4, and it's coming from the left, goes to -infinity. This one, the limit as x approaches -4 from the right, it goes to +infinity. All right. So that had to do with 6 through 10. 12, 14, 16, and 18. You're just saying where it's got a graph there, you're saying where the limit is going to. Super easy. 20 and 22, you've got to find the horizontal and vertical asymptotes. Any question there? And then 24 through 30, you've got to find the vertical and horizontal asymptotes, x and y intercepts, and sketch the graph. Any question there? It's all about the same. The only new thing today is this whole limit thing.
And we already kind of did a formal.
Right, exactly. So it's really not that new. Okay? We good?
Yeah.
Okay. So that means you still have like 7-8 minutes if you want to get started. I do have it posted.